Hello all, today I want to talk to you about resistor color code. So this is a very simple topic. All you have to do is read the color code and do a smallish calculation. So first let's take a look at the color code itself. So here's the picture of the color code. Let me make it a little larger. And you can see, guys, that each stripe on your resistor corresponds to a value. So most of my resistors are 4-band resistors. I don't think I have any 5-band resistors. And almost all of them are gold band resistors. In other words, there is 5% tolerance. But first, let's take a look at this example on the top. So the first band is green. Green corresponds to 5. Now look what I'm looking. I'm looking at the first band column. All right, so I'm going to go ahead and put that down. So green is 5. Okay, so next one over here is blue. And this is the second band. So I go into the second band column, I find blue, and it says 6. Okay, so that's what I'm going to write down. Blue is 6. So next one, let's see, is my third band. Now you always want to check if your third band is your second to last band. If your third band is not your second to last band, then you have a 5-band resistor. That's a little different. Now we're looking at the 4-band resistor. This is the third band and this is the last band. It's a second to last band. Therefore, it's a multiplier. So the band is a multiplier. That means that I'm looking in the multiplier column. Now this one is yellow. So it means it's in the multiplier column. I find it and it says times 10k ohm. So let me put that down. Times 10k ohms. All right, so this is what I have in the end. I have a 5, I have a 6. I just write them next to each other, and when I write them down like this, I get a 56 times 10k ohms. So when I multiply it out, I end up with 560 kilo ohms. Very simple. Okay, so let's do another example. The second example I have on the same picture is a 5-band resistor. Five-band resistors usually have a smaller tolerance, which is why I don't have them, right? We also didn't talk about the tolerance in the last resistor. The last band is always the tolerance, and in this case it's silver. So silver means it's 560k ohms within 10%. So what does it mean that it's 560 ohms within 10%? Well, it could be 10% more than 560k ohms, or it could be 10% less than 160k ohms. So it's really a big interval. So let's figure out what is 10% of 560 kilo ohms. Well, 10% of 560 kilo ohms is actually 56 kilo ohms. Notice that this is a huge number, guys. We're in kilo ohms. These are actually 560,000 ohms. And the tolerance is 56 1000 ohms. It's a very, very large tolerance. So now to find the region, we find the lowest possible value. Lowest possible value is your stated value, your ideal value, right? That's 560 kilo ohms. Let's write down that this is an ideal value. Why am I calling this ideal value? Because that's what it's supposed to be, okay? But really it's not. It could be anywhere from between the lowest possible value to the highest possible value. So the lowest possible value is ideal value minus your tolerance. Now make sure that your tolerance is in ohms. So that means if it's 10%, you already have to find 10% of 560 kilo ohms. It's not in percent. So let's actually do that. This is 560 kilo ohms minus 56 kilo ohms. And I'm going to end up with 504 kilo ohms. So that would be my lowest possible value. We also have the highest possible value. That would be ideal value plus the tolerance. So here we go, ideal value plus tolerance. Now guys, I can't stress this enough, don't add percents to ohms, okay? Make sure your tolerance is in ohms. Okay, so this one is 560 kilo ohms plus 56 kilo ohms. And that comes out to 616 kilo ohms. All right. So what is the actual value of the resistor? Well, honestly, who knows? It could be anywhere in this region. It could be anywhere from 504 kilo ohms, and this is where I'm going to put actual value. We don't know what that actual value really is, right? Anywhere from 504 kilo ohms to 616 kilo ohms. Anywhere in that region is a correct value for that resistor, and you should plan on having a resistor in that range. So the really big thing to take away from this, guys, is that there is no such thing as a resistor of exact value. You always have some sort of tolerance. Now let's take a look at the second resistor we have on this picture. Now this one is a 5-band resistor and it has a narrower tolerance. You can see that its last band is actually brown, and that's a 1% tolerance. Those I don't have any of those. Most of the resistors in my class are either 5% or 10%, but I don't think I have many 10% left, so it's basically 5% tolerance. Okay,